go over all the parts we're going to use on this engine prior to building it, I like to explain what we're using, why we're using it, and what the goal is, and kind of a little bit about what we're going to do before we start the engine build. So I got the case back from the machine shop. It was already line bored once, and I don't think it had that many miles on it, and we confirmed that over at Brothers VW Machine Shop. That's who does especially 36 horse. Anyway, so I took it there. They got the cylinders open for 80s. We got new case savers put in, and they installed the case savers for us. What I have to do myself is remove all the plugs here, and here, down here, and whatever, all the oil plugs for the galleries or galleys, whatever you want to call them, here, and then there's one back over here. Remove all these, and then with these old cases, they recommend, Brother said, you know, you really should do it on this because a lot of times they're really old and they might have oil that's, you know, or dirt and stuff that's stuck in the areas, and it's better just to be safe than sorry. So especially with the kind of money for these parts, we want to make sure that we don't have an issue. So I'm going to go ahead and clean out the case, pull all the plugs, get some brushes, bottle brushes, and then clean it. And it still has a little bit of like oil residue. I'm going to clean all that off really good, and then I'm actually going to paint the case with this stuff, Cerakote. This stuff's really good, but you just have to rough it up really good, and it goes up to, I think, I don't know, 500 degrees Celsius, something like that, crazy high temperature, and it adheres pretty well. But of course, when you do that on these, you gotta mask off everything. You don't want to get any of that inside, so all these holes have to get masked off, and then paint the case and make it look really cool. And this one here is a copper color. I thought it would look a bronze, burnt bronze, so it's gonna look kind of neat. Give it that aged look that we're looking for. And this stuff's really good oil resistance, so hopefully this works out well. This is not just a spray can deal. This stuff's not cheap, by the way. So anyway, for this build, we're using stock rebuilt rods. I got these at a swap meet, a really good price, so I thought, well, we'll just run with these. So you really don't, I mean, a 36 horse doesn't have that much power, so I think these rods, because look at the H pattern they have on these ends and stuff, these are pretty strong. I believe they're plenty strong for the amount of power we're going to give it, so we're going to use stock rods. We're using a 26 millimeter Shattuck oil pump because we are going to do a full flow cover. New bearings, AA Performance. These come from BBT. So the two sponsors on this video on Fit Series are Wolfsburg West. Wolfsburg West provided us a really excellent deal on these parts so that we could be able to show them to you. So it's awesome that they contributed a huge amount for this. Same with AA Performance. Always, again, they help us out with you know, really low pricing, so that we're able to afford to do this. And so these come from BBT, so that's how they come in to the country, or through BBT. So that's where the 36 horsepower bearings, basically there's one supplier that has them. I haven't even looked at them yet, but anyway, so those come from there. So the crankshaft, this is a Wolfsburg West, I believe it's their product, I believe they make it. A lot of their products are outsourced, of course. They like to do business with Taiwan. This is 4340 chromoly, and it's counterweighted, 69.5 stroke. So they do make a 74, but to do the 74, you run into a whole lot more complications. I was going to make a video on that, about the stage 1, 2, 3, and stuff like that on these engines. We'll be doing that in the near future, but this is kind of like a stage 2 because we're using a 69.5. So we got a new set of push rods, also again made by Wolfsburg West. Excellent sourcing, high quality parts. Tony really goes over the top to try and get everything to be the highest quality he can get. to be the closest to German engineering as possible. So really, to me, his stuff is excellent. So we're going with their push rods. These also may need to be lengthened. We'll find out later. We may or may not need to do that because we may not actually have a wider engine, depending on deck height when we get to that. So camshaft. Here's the camshaft that they have from Worksport West. Is actually replicates the Stage 2 Okrasa build that they did back then. So what Okrasa did is they had two kits, I believe. They had one kit that had the 69.5 crank, and it had the heads and stuff that we're using on this. They also had another kit where you just bought just the heads and stuff like that and added them to your stock engine, which gives you, I think, what, 52 horsepower? I'm going to guess. It's either 52 or 54. I can't remember. Here's the cam specs on here. They're really small. So, but if you look at here, these are at 0.050, 227. So I don't really know what the advertised duration is. So we don't really know. And the cam lift's only 345. So what this does is it's a nice spec right here, because you can take this and at AA Performance you can add the ratio rockers. So if I feel like when I get done it doesn't have enough juice, I'm going to hit the ratio rockers and throw them on there, and we'll see how that does. Because they sell the ratio rockers, the 1.15, I think they are, ratio rockers at AA Performance makes them. So I'll add those to it if I need to. But the way I looked at it, this here is a decent grind for this size engine. If you go too big on this thing, it's going to be really, and the stock ones are like, I think the lift on a stock cam is 295, I believe. 295, little tiny thing. So we're going to a 345. That's a heck of a size increase. So that's going to help. And with the big valves, so you have to factor all that stuff in. So if you're using stock valves, you can go with a bigger cam. Maybe with the bigger valves, you may not be able to go too big on the, because you're going to get so much air and fuel in there, and we want to kind of meet that right place where the air and fuel mixture is just right with the amount of size of the engine we have, and compression ratio and all that. So we have, these are opened up for 80 and 81. Just so you know, if you wanted to go to 80s, AA makes 80s, and you can open it up. It's the same opening for either one. We found that out over at, so the ones the cylinders and pistons I have are 81s. So we're going to have a 69 by 81. With the stock, with the actual, the ones that they come with here, the carburetors from Worksport West. Some guys were saying you could upgrade these to have them rebushed. So we may end up doing that later, but we're going to put it together for now with just those. And if the shafts start to wear out on these, I don't know if I'm going to drive it that much anyway, but if they do, then I'll maybe put a video up on rebushing them, you know, which should be done either, you could do it with a drill press probably, or a mill, but you got to have a really straight drill going through there. You can't have it a little wonky, because if you do, it's, you know, that's not gonna, that butterfly is not gonna close properly. So there's that. So we're gonna put on the stock air cleaners, the stock, all the stuff that comes in the Okrasa kit. The way it is, we've already got the tin opened up. The way that you have to do these, and the reason I don't like to go with the other carburetors that you can put on, is you have to put the tin and the manifolds on at the same time. So, and then you put the engine in the car and you can put the carburetors on. So it's not that easy to do. So a lot of guys, because you can't get to this bolt here. If you go inside here, you can see down in there, you cannot get to that bolt anyway to take the manifolds off in the car without the tin. So you have to do the tin and the manifolds at the same time. So the guys that run the like 40s or something like that, it's a lot more work to try and put those on, because you have to kind of assemble everything at one piece in the car, and it's, you know, put all the tin on it and put the oil cooler on it and put the fan shroud on. And so if you can imagine getting the oil cooler bolts on in the car with the fan, you'd have to have the fan housing kind of in the way. Not easy to do. So that's why this is, to me, probably the best way for me. So there's a lot of options, a lot of things you run into doing it the other way. Again, I've never built one of these this way at all. Never really done a 36 horse. So I'm teaching you guys as I learn it. So I might miss a few things. So what's nice is at Wolfsburg West, they have these 81 millimeter pistons that are forged. Okay, forged is much better than the cast piston. They'll take a little more heat. So we may end up getting a little hotter. Depends on what fan I run. I still don't know what fan I'm going to run on here, what will fit in that fan shroud. If I can run something, like if I can run the 40 horse fan or the 1600 fan, the early 1600 fan, I'll probably try and do that versus the 36 horse fan. I'm not sure. I think this one's a 36 horse fan, so it doesn't have very many fan blades on it. So it's this one here. And the 40 horse, I believe, has twice as many, or more than this, or maybe they're the same. And then the 1600 has more fins. So I don't know if it'll fit. If it will, I'll try it. Which will cost me some horsepower, believe it or not. It'll actually take away a little bit. So I'm not sure. You can always comment below on that. I haven't got to that yet. So we'll think about that one. So again, these heads have larger valves in them. And they're twin port. So this is what comes in the kit. If you guys haven't watched the kit video. These are dual port. You have to cut the tin to get them to fit, and the stock tin, and they the ports are nice and smooth. I don't think I'm going to do anything to these. They're so nice. I can feel they're cast. I mean, I could smooth them up a little bit, but yeah, I mean, they're really, the flow of these is amazing to me. I didn't check this one. Oh yeah, no, the exhaust flow, I can feel it. It doesn't have that hard corner like the 1600 heads do. So these are really well made. I mean, these are really nice. I mean, if this is how the original Okrasa ones were, and they're supposed to replicate them exactly, I can see why you got that much more power out of it. So, because the head flow on these is actually pretty nice. From my opinion, from looking at them, I think they're just super nice. So I haven't machined the heads yet. And again, the reason I haven't machined the heads now is because I want to assemble it, figure out what my deck height is. Because remember, we got a stroker engine, so we're gonna have a little bit tighter deck height. Definitely gonna have tighter deck height, and the piston might be sticking out a little bit because I got stock length rods. So the piston might be sticking out a little bit. Then I'll figure out how much shims to get. So the only people who make shims for this are Wolfsburg West, by the way. So I got some of those. I got like 2 sets of 20s, and they are not cheap, by the way. But I got 2 sets of 20s, and they did give us a deal. But I'm just saying that, you know, keep that in mind. Some guys will go and take the pistons. I'm like, Brothers Machine Shop does them this way, where they take pistons and they will actually machine the piston down. But you know, I don't really like to do that. But you know, what you do is you have to measure the thickness of the piston and see if you can see how much you can take off, because you have to have a decent amount of piston there, right? So guys will actually deck the pistons on these and do them that way. So I don't know exactly what I'm going to do yet. Oh yeah, somebody mentioned in the comments that they had got a set of these and these pistons, the 81s, and they have really thin rings and they didn't seat. My question to you is, did you oil the rings when you put the engine together? I talked to several engine builders, and including ourselves, we assemble the engine with the rings dry. No oil on the rings, purposely, because that helps them seat. And I talked to several other engine builders, and they say exactly the same thing. It's up to you, but maybe that's why they didn't seat. What's his name? brother's machine shop uses a similar piston with really thin rings, and they don't have issues. They use an 80 millimeter piston. It's not from AA. They have a forged piston that they use. They're kind of expensive, but they have really thin rings just like these. So that's why we're going to try these and see. I don't think we're having an issue, but maybe that's why. Somebody mentioned that they had issue with the rings not seating, and I think that might be the reason why. Dry, you guys, dry. No oil on the rings. I put a little bit on the skirts, nothing on the rings. Put it together. 30 seconds after that motor's fired up, the rings are seated. What I'll also do, what I'm going to try to do, is open these up. That's why, again, I haven't machined them yet. Is open these up for 80s or 81s. Either one, they're the same. So these are 81s that we're using. And I will open this up for 80, 81, and then I will have them step cut. I'll show you. Let me do that. Well, I have them take, I mean, if you look at the thickness on these, thickness is still pretty good on these. It's not like a thin wall 92. It's pretty standard looking. So yeah, there's plenty of meat there. So what I'll do is I'll have them open these up. Now I'm not sure if the head size needs to be different, so I gotta take these down with me when I go down there. They haven't measured this in. And I'll have them cut these open for these. And then I'll have them step cut the head so that it'll be, say, you know, a little bit wide open, more open, like that much, you know, another 10,000ths wide open than the actual opening. And then that will ride on the cylinder, and then if my piston's at 0, okay, or at 5,000ths or whatever, it'll be like I'll end up with a nicer combustion up in the head versus having it fire in the barrel. So we'll talk about that later in the video series on this engine. So again, I don't know what we're going to do there yet. So that's why I didn't have them machined, because I'm probably going to have them step cut them, which will be like a little step. Yeah, here's a 1600 fan. Look how many more fins are in there. So, or new, that is a 40 horse. I don't know. Sure is rusty though. Let's see if you guys can see this in here. That's a step cut right there. Okay. That, let me get you up like right here so you can see right there, that's a step cut. Normally this would be flat all the way across, but that little step in there, that's what I'll do, and I'll make sure that that is larger than the cylinder. So after they're done getting machined, I'll drop my cylinders down and make sure I can't see that edge at all. Okay, then I know that my piston is not going to hit, because there is always rod stretch. When your piston goes all the way up, it'll stretch the rod just a little tiny bit, and that, you know, they say deck height needs to be at least like 45 thousandths. So I'll probably tighten it up just a little bit. I might even go to like 45 or 50 instead of 60 deck height. Stock is 60 deck height, so I might go a little bit tighter, and that way I'll end up with a little bit higher compression ratio with those 50cc heads. When I do these engines, I have rough calculations ahead of time. So I've already figured these are 50cc, all right? I know that they're 50cc, I checked them, and I wanted to know, okay, what the procedure is going to be before I start the engine build. Because we're going to the 8 dowel crank, and that's what's nice about these. These are 8 dowel, so these are stroker counterweighted 8 dowel. That makes a huge difference in the way that engine performs and goes down the road. This thing will take a lot more RPMs, and because we're going with that, we're going to run more RPMs. We're going with a 26 millimeter oil pump instead of a 17. What came in these things, a 17. If you're running one of these and you decide that you want to run it at higher RPMs than 3000 RPMs, believe me, take the oil pump out. So if you're going to do just this kit, if you were going to just put on just the head kit, I would absolutely recommend changing to at least a 21 millimeter oil pump. Take the 17 out and, you know, put down the ducky and get rid of that one and put in the old 21 at least. Okay, but we're going to a 26 because potentially we're going to put some sort of full flow system on this. I don't know. So we're going to go with a little bigger pump. This is a Porsche flywheel for 356. This is a 6-volt gear. All right. Volkswagen clutch. 200 millimeter flywheel. It's not a bus flywheel. It's a 200 Porsche 356 because it has a small dowel pins and everything, and it takes a special gland nut. So if you order one of these, make sure you get the gland nut. This is a chromoly one. I don't know if they make anything other than chromoly for that, but this is a chromoly gland nut. So we're going to go with the Porsche 8 dowel flywheel, Porsche chromoly gland nut, and it's still 6-volt here. It's 200 millimeter, and it fits on a 36, and it's 8 dowel. So you can add one of these. Is really cool, and it's lightened. Because remember, if you go with a counterweighted crank, so if you're just going to go with the stock crank, I would not put this flywheel on. Okay, you need the weight with the stock crank. If you're putting a counterweighted crank on, you're putting the stress and the weights right here. Okay, this crank is a little heavier than the stock one, and that's why guys they really invented the lightened flywheel. That's why the Porsches had the lightened flywheel, because they had the counterweights on the crankshaft. So counterweighted crank, lightened flywheel. I do it every time, even in a bus. People go, what? In a bus you need the weight. And no, you don't, because you got the weight right there. It's on the crankshaft. This is fine with the lightened flywheel. It'll still, you won't even notice the difference. I drive my buses with lightened flywheel and a counterweighted crank, and you can let the clutch out. It doesn't want to stall or anything like that. But you put a lightened flywheel on with a stock crank, oh boy, it's gonna, it's like real easy to stall the engine when you let the clutch out. So anyway, that's why they made the lightened flywheels, is to go with that crankshaft, the counterweighted crank. And so, just so you know, I had these pushrod tubes that I took out of the engine that were original, and they still have the logo on them, and they were absolutely perfect. I mean, there was the smallest amount of surface rust I've ever seen on these. They almost had nothing. They were coated in some oil, and that kept them surviving all this time, and these things were like mint. So I went ahead and rescued them and kept them. So we're going to run the original pushrod tubes. Yeah, they're used. Usually I'll put new ones on a good engine when I'm spending this kind of money on parts, but these ones here were so perfect, I just decided to run them again, because they really were just like brand new. I put them in, I took them out, put them in degreaser in the sonic cleaner, cleaned them, and then you could barely even feel any roughness from the rust. I mean, there was no pitting at all, and nothing. And I just put them in some rust, what's it called? Evapor rust, and everything was disappeared, and they were perfectly smooth, like a baby's butt, perfect smooth. There was nothing, no pitting at all. Even from the surface rust was so minor. So I figured, well, we'll run those again, see how they do. They probably, and they feel a little bit heavier than the aftermarket ones. So I thought, you know what, I think they're gonna. Okay guys, I'm here at Brothers VW Machine Shop. Excellent place to get machine work done. I was going to show you guys a couple things here. This is the 80 millimeter from AA Performance cylinder. Okay, if you notice, it has this edge on here, and a lot of times they have to machine this down so they'll fit together, because they'll touch right here. Sometimes when they deck this a little bit, it ends up being a conflict, and they have to kind of clean that up a little bit. With the 81s, if you notice here, they don't have all that. They're round, more like the other cylinders are in the other performance ones, for your 1600s and stuff. couple of really other cool options. Like they build these here, so they have these forged pistons here for the 80s. So they'll use the cylinders and then use these forged pistons. And check out these rods real quick. So these are 3/8. So this is your rod, right? This one's your rod?
No,
that one's yours. The lightweight one. So this is the AA performance rod. Let's look at the weight. 555.2 grams. Let's look at this one. 490. I was saying it was 100 grams. I was pretty close. Wait a minute. So if you want some lightweight rods for your 36, and these things look like really good quality, they have them at Brothers VW Machine Shop. Crazy. And then they show like this. It looks like it's a lot thinner. All right, so I went back to the manual and figured out that I guess what you have to do is put the intake manifold and this all as one assembly. I don't think it's going to matter whether you cut out the way I did or leave the little thing there. As long as you slide on those little things. We never lip them on there. I've never done that. I've always just slid them up there to cover the hole. As long as they're covering the hole, that's fine for the spark plug wires. And this should be fine the way I've got it right now. But you have to put it all as assembly. Put this on and this on all at the same time. All right, so we're on pre-build right now. I do a lot of stuff way before I get to building the engine. That's actually probably the easier part. But what I do is I'll set the bearings in place, and at the same time while I'm checking them to make sure that their thrust cut is right, that they fit, and I've checked them on the crankshaft to make sure they're correctly in the box, fill a proper amount of plate. I'm going to put them in place with the dowel pins in so that I can mark the bearing. I'll show you in a second. All right, so it screws me up when I'm holding the camera because I started putting the wrong bearing in. Of course, when I'm looking at it, I know where it goes. So I'm going to mark right here the case, and I'm going to mark not the case but the bearing. Okay, and I'm going to mark here. You kind of know where this one goes because it has that little shape right there. And mark these here. If you want to, you can even kind of go like that. That way you know that that goes to the back of the car. And this one, same thing. Okay, we'll just wipe that off like a dry erase marker, right? Kind of does that when it's still wet. And then we'll mark here. Make it a little easier when I'm setting the crankshaft in. Like that. All right. All right, I got to tell you guys, these 36 horsepower motors are way different than 1600 and stuff. But, so you got your dowel pin here, and you can see, I got you guys out of frame there. You can see the dowel pin right here, and it's right in the middle of the oil groove, because there's no oil groove in the bearing. So what I figured, this could go on here either way, because the dowel pin's centered, all right? So I figured that the oil hole that's closest to the dowel pin should go here. That's it, because the other hole's way over here. And if I put it on the other way, the hole would be up here. It'd be up here further away. So I think it's better if it has the oil closer. I don't know if that's correct or not, but that's how I'm doing it. So I marked my bearing as such with the oil hole over here. Of course, getting the gear hot, gotta flip it over, like, you know, like making eggs or whatever. Just get gear hot, flip it over a little bit. tapered side to the back. And the spacer. Brass gear. All right, so if you're wondering where you get these to put the snap ring in, you can get them on Amazon. These are Knipex. Knipex, I guess. I don't know how you say it. Everybody's got a different way. But anyway, make sure that ring is all the way in. And this one is. You can always take the ring and put it in the groove and make sure it's straight up and down before you put it in. I didn't show you guys that, so I didn't. I put it on. We're all the way in. It's tight. This bearing. Again, on the 36 horse, they don't have an offset pin on these. So you got to check everything. See the little oil hole there. All right, that needs to line up with that hole. So that's how you kind of know. From what I can tell, like I said, I've never put one of these together. It's definitely different than the other ones. And usually this thing's on this side, so I think that's where we're gonna let her land. All right, so the rod bearings on these, I'm just gonna use a little bit of Scotch, just like a light Scotch-Brite, and just remove the coating that's on here. This coating that's on these, I believe, is just, and I'll wipe them clean with a rag after that. This coating that's on here, not pushing on it very hard or anything like that, just kind of getting that stuff off, and then the little bit of left that's on there will help hold the oil. I believe this coating that's on here is just something that's on there to protect the bearings while they're in storage, because we used to find it in the oil. Somebody said that you're not supposed to remove this, but I think what they were talking about, what's on the Cleveite, I'm trying to think, they have a black coating on them. No, you don't remove that stuff. That stuff's there. That's a special coating. I mean, they have bearings that you get coated with this special coating, and I used to just use a rag and wipe this stuff off, but the shop used to do this, and all it does is just, it looks like it's sanded or whatever, but it's really not. It's just barely taking that off. Then I'll take acetone on a rag and clean them, and then we'll put them in the rods. I'll clean them with a bit of acetone, like that, just to get off whatever residue that loosens it up. You can see that's just perfect. It's not scored or anything. Just clean off all that stuff off there. That's why I've done it for years. I've done, I don't know how many engines. I did my S10. I remember back years ago, I did my Chevy S10 engine, and I did like a used parts rebuild, put brand new crankshaft and camshaft and everything in it, cleaned up the pistons, and I did I just put new rings in it. That engine ran better than it did. My dad bought the truck brand new. It ran better than it did when he brought it home from the dealer. It always kind of had a little shakiness to it, and the intake manifold vacuum had a leak, and it's somewhere because they didn't properly put the gaskets on, and it never had that again. When I was done with it, it was just ran absolutely perfect, and I put like 70,000 miles on it with used pistons. I've done this before. Okay, but I've done a bunch of VWs too. These are all cleaned up. Put them on. When I put the bearings in, I don't push here in the middle. Push at the ends. Put them them in the, just kind of make sure it's all the way in like that. I push on the ends mostly. Same as the rod. Hold the bearing like this. Stick it in here. It's hard to make sure I'm in frame and pushing on this in the right place. Okay, and I'll push on the ends. Get it in place. Oil them. And put them on like that. And put a little bit of oil on the threads of the rods. One thing I wanted to point out on these is, unlike the 1600, the numbers or the aftermarket rods and stuff like that, the numbers are on the same side as the tangs. That's the tang right there, and that's the number. So I had to stop and kind of figure things out, because I've always thought numbers up, tangs down, and it's going to be numbers down, tangs down, I guess, because that's how it goes. I mean, I couldn't find any information on the 36 horse. I was looking at stuff like the oil holes here are the same. Unlike, I think the 1600 has them facing different directions, so that's why they have to be down, but I don't know. I'm going to go with tangs down. Again, oil the threads. Oil the base. Grease it if you want to use that other high pressure grease. I think either one's fine. All right, so you peen the rods. I do all these. This is only on the 40 horse, 36 horse. Oh, wrong way. There's like a little groove in there. And you just kind of knock a little burr in it. Hey, let's take a look at something here. So putting the cam gear on. Maybe you don't know how to do this. If you look at the back lobe, the one furthest from it should be down. And the timing mark, if you can see it, should be up. So back lobe down, timing mark up. Now I'm going to show you something else too while we got it here. I got the stock cam. I had to kind of remember this stuff. It's been a while since I put a cam gear on. I've gotten these regrinds that I'm getting, and they're really a good deal, the way to go, if you guys wanted to know. If you can, I don't know if you can even see it. Maybe you can, maybe not. Look at the lobe difference profile on that. How much more duration there is in this cam. Remember, I always tell you guys, the weak point in Volkswagens is the cam duration. Look at how much flatter that lobe is than this one. That one's pointed. That one's way flatter. So it's got way more duration. It has more lift. You can just look at it and see it. I mean, it's got way more lift, way more duration. So that just gives you an idea. This is a way bigger cam than the stock one. So the 227 at 0.050, it could be, from what I looked at, like 260, 270 or more duration. So yeah, and then if you go to the ratio rockers, it takes it to like 400 lift. So like 400 lift and 260, 270 somewhere in duration is a lot for that size motor, but the duration will really help it out a lot. So anyway, I could add the ratio rockers and give it a lot more juice. I mean, a lot more cam. So anyway, duration is the key. That's the biggest thing missing on stock cams, VWs. So remember, the lobe down, mark up. You can see the line here goes up. So I'm still kind of in mock-up. I've still got to take this all apart. I've got some machine work to do here, but I wanted to put this crank in and check it. A couple things. I wanted to hear this. If I can. There's just a little tiny bit. It's pretty tight, but it's fine. If there's anything, it's okay. So there's a little bit of noise there, which is good. This gear is going to wear in a little bit because it's brand new, and I can feel just a tiny little bit of, hear it? Okay, a little bit of gear lash, that's what we want. So another thing is, because they only make a 0, so anyway, another thing is I check the clearance. Let's rotate this around a little bit. You can see it hits here, right? But that's not where the rod's going to be. It's going to be over here, right? It's going to be on the piston. So that's what you check for. You don't check where it's way over here. You check where it's supposed to be. It's supposed to be here. If you look where the rod is here, all the way up, right? There is still, I'd say probably 3 millimeters of clearance or so. So even with a 74, you might not have to do much, but you might have to do something with the 74 setup. So just a little bit with one of those finger sanders, the belt sander. So yeah, we don't have to do anything. I've rotated this around. I've checked for places that it could possibly hit, and it does not. So it's pretty, it's just kind of goofy where it's at. Oh, I got the rod stuck. All right, guys, so we ran into a problem here. If you can see where the rod is, it would be right here, centered, and it hits the cam lobe right there. So I marked it black. So I you know, this is stuff we don't know. I thought stock rods would work. But, you know, if you guys are going to want to not have to do what we're going to do right now, I think we can machine off that corner without damaging anything. So we'll do that and gram scale them up, make sure they're done, maybe do both sides a little bit. But yeah, George wanted to see it because he's like, man, what the heck? So yeah, it does hit. So we've got the cam in. We do have a little bit of play in this guy. I know I've checked it. Hear it? Anyway, and just a little, it's real tight, but it's perfect. It'll work. And then we're just gonna see if we can machine these versus buy a new one. So if you wanted to, you could buy the clearance rods, but we're gonna go for just machining the corners off. Knock the corner off. It's not into the threads or anything, just the corner. So if it was into the threads, then you kind of go, no good. All right, talk to you guys a little bit later. All right, so we were noticing that we measured these things on the gram scale. We're kind of trying to get them balanced. So, and we noticed this one was, this is a light rod, and this one's heavier by quite a bit. And if you notice, look at the back side of this rod, right here, and look how thick this one is. The ribs are deeper, and from what we've had back in the old days, is how they did it. They lightened up rods by doing this stuff, or made them clearance that way. Oh, now it's 418. Mm-hmm. Yeah, we're really close. Yeah. So they're both 418. Oh, so you got that one down same. So that's what we're doing, is we're taking it off where the casting is too thick. And this is the way the good old Remco used to do it years ago. That's why we got them. So we're doing that. Plus we're just cleaning up the ends, that a little bit, so they clear that and getting them balanced. So it'll be real nice. All right, guys, there's tons of mock-up to do on this thing because, I mean, this thing never came with a 26 on it. So I don't know. Yeah, they should be the same, right? But I've had to grind this end down. So that's magic marker. It's magic marker. So I put this on here, put the cam in there, spin it back, you know, do a little bit of this. I'm having to grind down my bolts a little more. I need to make sure they're plenty of clearance. They're barely touching right now. The one is. I want to make sure that they don't hit. You see how much I had to grind that? Okay, grade 8 bolts. I mean, even the ones that are supposed to, kit ones, I looked at them, they're not. I have some of those and they're too long for this. Because again, this one didn't have all that. So another thing is I put this gear in. You really got to check these oil pumps. I mean, even on all your engine builds, you should check them, but see how far out that is? No good. So yeah, I'm going to have to probably, I'm probably going to have to take a little bit off the end and then take a little bit off of the shoulder. Yeah, off of this shoulder right here. I'll probably have to take that, grind a little bit down so that, you know, maybe a, I don't know, like 50 thousandths or so. And yeah, I'll just have to take cutoff wheel. I'll real carefully grind that off of there. I cut myself. But anyway, and get that nice and straight. I mean, all that thing does is just sit in this groove, right? It's not like it's super perfectly machined. And the oil pump, you know, it turns the oil pump in that groove in there. So anyway, if I just cut away a little bit there, it should be all right. But it's got to be, it has to fit. This is all the stuff that on these 36s, man, you got to really watch it. Because when I put it in here, it was sticking out, you know, like that. And, you know, there's the gasket thickness, but that's really nothing. I wouldn't even, I'm going to make sure it fits without the gasket surface. And then when it adds the gasket, that whatever 1,000ths or whatever, that I don't want it pushing on the cam at all, because that will just wear this out. And who knows what else. So it should be just riding there. It's a lot closer than it was. I'll get it all tightened up and then I'll show you what I did. Now let's see what we ended up with here. So what I did, if you can even tell, I don't know, let's see if I can get you guys up close enough, is I had to ground this part where it's black. That's magic marker that's on there. And then I ground, if you can see, this pin, I had to grind slightly below the surface. Okay, about 5-10 thousandths in there, so it doesn't matter. As long as it's below the surface, because if it's above the surface, okay, when I put this on and I tighten this down, okay, get you guys back a little bit so you can see. Okay, so I get you guys back. So if it's not below the surface, and when I turn the cam, right, it could have one little high spot, and then when I turn this around, that'll push the gear out. It'll rub against the housing and put metal shavings in stuff. We don't want that. So a little bit of precise, you know, backyard machine work, and that's fitting on there nicely. And so again, I'm gonna sit there with a file. I don't know, now that I'm done, I'm gonna clean up all the little burrs around the edge. All that's got to be off of there. We don't want those little pieces of metal in the oil. So this is the type of thing that I like to do, you know, make sure it's right. And I've still got to plug this oil pump because we're full flowing. And then I want to see if there's a way to drill this opening up a little bit bigger, maybe. Just gonna really look at it, or at least kind of open the mouth of it up a little bit so that it has, you know, it matches up a little bit better. If you notice, there's a big difference. So if you look here where the hole lines up there, get in there with my borescope, I guess, and see how that lines up. I know the dogs have been just whining all day long. Poor neighbor. The dog's just, so I'm gonna try to open it up. Maybe I can open that up just a little bit bigger. So I'll take this screw out, open that up. I've already cleaned all the passages out of here, put plugs in it. All the plugs are done. So I've cleaned out all the gook out of there. There wasn't much, really wasn't much at all. I probably didn't need to do it, but I did it anyway. So anyway, I'm gonna take that plug out. I don't know how big that is. It looks like it's bigger than this. I'm gonna measure this stuff, measure that, measure this hole, and see if I can, if it will help any, if I drill that out a little bit bigger, and then maybe kind of open it up a little bit more so that it matches. It's nowhere going to get near that. Okay. All right, guys, so let's take a look here. I've got everything masked off. I cleaned this, sanded it with Scotch-Brite, the whole thing. I kind of wet sanded it using Scotch-Brite and spray gun cleaner. Hit it with silicone, anti-silicone. It's a wax and grease remover. And I've done everything I can do to clean this thing up and prep it. And that's as good as it gets to look. So that's why we're going to paint it. So we're going to hit this thing with some Cerakote. See how much better it looks. I've got it super clean, sanded. Doesn't look like it, but it is. All right, so before I decided just to change it up a little bit here, guys, I went to the H-Rod, and there's no middle ground on these things. Either you do H-Rods or you do stock rods. The stock rods are basically marginal, and it's not just one reason why I'm going with them. There's a few different things. The rods I had, I just wasn't really happy with the way they balanced. It looked like there was two half sets. A couple of issues with them. They were just like, they just didn't balance. I wasn't real happy with the way it balanced. And they're already kind of marginal, okay, with this horsepower upgrade we're doing. I mean, what we might be at like 60, 65. I don't think we'll hit 70, but let's say we were at 65 horse. I mean, it's very possible. You know, with those rods and them not being balanced very well, you know, it just doesn't seem to make sense to save a little bit of money. These are, they're not cheap. Nothing's cheap for a 36, but there's no other option. You don't have like a middle, like if they had I-beam chromoly rods, that's what I would have used, but they just don't have them, you know, so we're switched to the chromoly. I'm not going with the ARP bolts. I don't think it's really necessary on this small of an engine. We're going to use the China bolts, which I use, you know, I've used many times and had no issues with them. Like on this bucket truck engine, I went with the ARPs because I am maxing this thing out. I'm floored all the time. You know, that's a lot of stress. So I figured just go for the insurance policy of the ARP bolts. If you're revving it to the moon, then yeah, but listen, you guys, one of these 36 horsepower engines, you're not going to be revving it. I hope you wouldn't. There's just the oil passages on this thing are tiny. So we're going to try and get as much supply up there as possible with this 26, and it's all going to be right up to here. What it does past that thing and goes into the case, I don't know. Definitely, I don't want to put very many RPMs into it. So the ARP bolts really aren't necessary for my engine build. I'm not going to try and, you know, win the 36 horsepower challenge or anything like that. So I'm not going to push it to the limit. You know, I'm just going to drive it. So I figured that would, the rods are a little overkill, but they're going to make it a little stronger and make me feel a little bit better, that I'm not going to be that worried about, you know, pushing it too hard. And then, you know, you got a $600 crankshaft, you got $600 pistons, you got a $250 cam, you got a, you know, a whole bunch of, the lifters are freaking $200 to $300. You know, all the stuff that's in this engine is super expensive, and just to save a few $100s to get the rods, it's just not worth it. I figured just put them in there, you know, since I've got all the best parts in here. That's just, you know, go big, you know, so we don't look back. Case looks amazing. This stuff is like part of the metal. That's why you want to mask everything off really good, okay? Because wherever this paint is, you aren't moving it. It's there. So this stuff is great. I would definitely recommend painting a case with this stuff. That's the only thing I would use. And it's supposed to be to 500 degrees Celsius or something crazy. So it should be fine. And it looks really nice. I just like it. I will definitely use that again on another, you know, this is a custom engine. We're gonna try and make it look nice too. So anyway, well, I'm gonna put this in the case here in a little bit. I'm gonna make sure everything's clean. I gotta blow this off one more time. Not today, I'll do it tomorrow. And then I'll get those, you know, gotta torque my rod still. And then the torque specs are on AA's website if you're wondering. So anyway, for the Chinese bolts. ARPs, they're super tight. You know, check their website. You'll be shocked how tight they go. There's rod, you can do the stretch method, or you can just torque them down super tight. But anyway, don't need to go there. Not for this engine. But I definitely wanted the rods just to be safe. I main bearing, check it. Looking good there. This is ready to go in the case. So I'm gonna go ahead and set this guy in. Make sure my oil hole is lined up the right direction. These you can definitely do wrong, I think. Make sure it's in the case nice and flat. All right, so that's good. Now I want to show you guys something here. Let's take a look. So I had to clearance the AA rods. They did not make it. I mean, I had to take quite a bit off. If you can see, there's still quite a bit for the threads. You know, unfortunately you get into that part of the rod a little closer than I like to be, but it's fine. You know, it's still stronger than the other rod. So anyway, had to clearance them. I'll show you how close it is. There you go. There. With the 0 is between the two dots, right? So we're lined up there. And we rotate this around to right here. And if you can see, okay, that's off center. So I bring it over to center. It clears. I don't know if I can let it push. But it clears this cam. And so I don't know what they changed in the later years. We can take a look. So here's the later model cam. You can see the lobes are in different positions. So the lobes are more lined up with not with the rods, but with the, you know, I don't know where the crank is, but I think it lines up not with the lobes, with the, if I recall correctly, on the later models. I haven't done that many in recent years. It's big stroker motors. I mean, it's been a long time since I took one of those apart, but if I recall correctly, the counterweights are what conflict with the rod cam right here. Okay, on this 36 horse, it conflicts with. See, it hits right there, and look, I'm off center though. So, but if it's in the middle, it clears. Okay, so same thing with the second lobe as you go around here. So I had a little difficulty there, but if you see here, this lobe here, right now it's hitting, but when it's centered, so look, right now it hits. Okay, where am I at? There we go. Centered is over here. So when it's centered though, it doesn't hit now after machining it. So it was that close. I mean, literally it hits the cam if it's not completely centered. So it's really, really close. And I put a feeler gauge in there. It's about, I gave myself about 15 thousandths clearance. That's about it. Of course, rod is stuck. All right, so I'm going to take it apart again and do a little bit of cleaning, but I wanted to at least put this thing together so I can get a deck height. All right, let's just take a look at the deck height here. See where we're at. Inches. We definitely want it in inches. That's where I'm used to working with you guys in Europe. I know I'm going to confuse you guys a little bit. A little better than we did last time. I'm at 69.70. So I'm going to say 70 thousandths. By the time I tighten this down, it's going to be a little less, but that's okay. So 70 thousandths up. So if I have an 80 thousandth shim, which I do have, let's look here. Got an 80 thousandth shim. 90 thousandths, 86, you know. So I said, everybody goes, oh, you gotta have it exactly tightened down, everything perfect before you can check your deck height. Well, got news for you. It changes because thickness of the shims is not exactly the amount that you calculate. So just, you kind of got to have a pretty rough idea. And then just don't go, when you get it done, check it. Then you put the stuff on it and tighten everything down and check it before you put your heads on. Yeah, that's the way I do it. Do it how you want. But anyway, well, to give me 21 with just 90,000 shims on there. That's actually perfect. Good. I thought I was going to have to put 120,000 shims on here. So that actually corrected. The rods are actually 20,000 shorter than the stock ones that I put on here. So I think, unless I have that in the video, then maybe that's just what I remember. I thought it was one, yeah, I think I was going to have to put down 110. So I was, yeah. I was going to put 110 thousandths in shims down, so yeah, 20 thousandths shorter is what yep, 20 thousandths. Okay, so pretty cool. One shim should get me to 0, near close to it. It's, you know, so if I tighten this down, let's say I'm a little off, right? We know it's going to be slightly off. We're going to find that out once we get everything. This is just to get my heads in the shop to get work done. So I'm at 16. So I could be at 16 and a half. Let's see where. Roughly 17 over here. 17 and a half. So let's go with the lowest number, 16. Tighten this down, I get 2 more thousandths, 3 more thousandths, right? I'm still at 10, let's just say 10 thousandths here. That's okay, because if I get this thing, take this cylinder down, and I have them step cut the head, let's say 50 thousandths step. All right, I'll have the 10 thousandths here, plus another 50 thousandths in the head. And if I tighten this down, and I'm 2 or 3 thousandths tighter, okay, or 5 thousandths tighter if I'm really wrong. Don't think I will be, but let's just say I am. Tighten this down nice. I'm 2 thousandths further down. I'm still at 45 to 50, which is fine. As long as it's not below 45. So I'll have them step cut it. And I got 20,000 shims I can add. So if for some reason, when I tighten this down, I can add another 20 in here just to get a little bit more deck height. Then what I'll have them do is open these up, step cut the head 20 or 50 thousandths, all right? And then I should be good to go. I'll calculate this out off camera, make sure, double do my math, and make sure we're good to go. Get the heads down to brothers, because it's always a wait. All right, bring you back in. All right, making sure I didn't forget anything. Got our cam plug. I think we'll run it that way. Fill that little thing up with oil, kind of give it a little supply area for the cam. It doesn't really matter, I don't think. But I got my cam lube on here. This, yeah, I don't know, whatever it is, high ZDDP stuff. A little Honda Bond, you guys. A motorcycle trick here, guys. And see which side of the case I'm putting this on? Yeah. Take notes. I'm not putting it on this side. Why? Because I got all the studs in the way, and the pins, the shuffle pins, and all that. I put up on the flat side of the case. And on this one, we don't have to put push rods in, push rods or lifters in. Thinking, trocking, and working at the same time. Guess we need it around that too. And then over here, be careful from the oil return. And then we need it right there. And we'll smear it with the old finger, with the old digit. Do it digitally. You don't ever want to hear the doctor say that. We're going to do a digital removal. Oh, God. All right, guys. So spread this on here. Put the case half together. I can do that too. And get her done. All right, so we got end movement real nice. It's a little bit tight because of the oil I use, but it's fine. It's in the way it's supposed to be range, so it feels a little tiny bit tight, but it's just, I think it's the oil. We're going to run a very, very tight deck height, and then our deck height's going to be a chamber in the head that he's going to open. We step cut the heads so that the chamber, so that the piston can be at 0 and not hit the head, or not 0, but we're going to go like 10 thousandths or something. So then we're going to have a pretty tight deck height of 40 thousandths above that. So in the head. So anyway, if you can kind of figure that out, you have to have deck height, but there's a lot of different ways to do it. Instead of running it in the barrel, we're going to run it in the head. It'll still have 40 thousandths clearance or 50 thousandths clearance between the head and the piston. You guys are wondering, push rods, still don't know yet. See, I'm trying to narrow this up right now. That's what we've already, I've been running machine shop numbers, and then I've got pistons that I might deck to bring the engine more narrow, okay? So I'll have less shims here, but I'm decking the pistons, or the heads, a little bit. So if I come out stock length, that's what I want to do. I want to kind of come out stock length so that my push rods are very close, and then I'll put them in with the lifters on the ends of them, and then instead of doing the cut to fit ones, those are very expensive, by the way, because you got to buy the lifters. The lifter sets are more than the stock ones, and then you have to buy the cut to fit push rods. I mean, you can use some old aluminum ones. I have some laying around. I could probably do that. Still haven't decided yet on that, but I think I'm going to try to do those, or use the spacers or machine spacers to my specs that are going to work. So I think we can do that without spending a ton of money. All right, so we're just going to install these step studs in here. Look here, they're stepped. If you look at the pattern, like you put your oil pump up there, you'll see that it's slightly more narrow, the distance between here. And so if you tried to drill and tap these, you might cut through. So I'm not going to take a chance at it. I'm going to use the step studs. Let's see how this fits. I'm going to put it on this way. I have to file the inside of these a little bit, because like I said, the stud pattern is a little bit inset. So I'm going to have to file around here, around there. I mean, I put this in already, the plug. There's a lot of work to do. Just that oil pump, I've got hours in that. One of the ways, just tried it. When it fits, that's the way it goes. Out on the top, right? Yes. Tight. She'll work. All right, oil here, a little bit there. Sure she drops all the way in. A little bit of oil in the shaft here. And a little bit of oil on the gear. Doesn't need much. Guys, just put all kinds of crap on these things, and really all it needs is just enough oil on there for the gears to kind of stick together. And once she rotates, that will create a vacuum, and immediately you'll have oil pressure. You don't need any other junk in there, because whatever you put in there is going to be in your galleries. Okay, it's going to go through all the oil passages. You got brand new engine. I get freaked out. I mean, I don't know, maybe it works. Guys use all kinds of crap. I've seen Vaseline. I've seen guys put grease in them. But listen, whatever's in there ends up in those little tiny oil passages in this 36 horse motor. And, you know, and you've got brand new bearing surfaces with very, very tight tolerances, and there's no space for anything other than oil. So this stuff's kind of thick, it's fine, it's an assembly loop, but man, anything else, I don't like to put anything inside one of these oil pumps other than just a little bit of oil, and that's it. Just a drip, enough on the gears just to coat the gear so that it creates vacuum. That's all it takes. A couple revolutions, you'll have oil pressure. It really doesn't take much. If you want to make your life a little easier, you mark your offset pin. Makes it a little easier. Always helps when you mark the right pin, which I marked the wrong one, so anyway. Bad lighting in here. All right, let's check it out here. It's at 32. Turn this again to 0. It's hard to zero this out. So there we go. Zero it out there. $32. I'm going to call it right there. So got some shims. They're supposed to be 10s. Let's see if they are. 28.5. And then we got the thickness of this gasket, because we don't have a gasket in there right now, so our thickness of the gasket is that's not right. 7 thousandths. Wait. I measured 4. That's about right. No way, that's 8 thousandths thick. Anyway, I measured it out, but I leave the gasket out when I do this because I want to try and not tear it, because you always end up tearing the damn thing. There's 32 right there. All right, let's see what we ended up with. I think it's a little bit tight, so that's at right there. It goes to 1.5 thousandths that way. 2, 3. Wait, let's just see. Maybe that is okay. No, we're half thou past 20. Let's just zero this out. Maybe we can get a look at it better here. So it's a half thou, well, maybe almost a whole thou that way. It's 4. You should be okay. I like it closer to 5, but I mean, I don't like it 3. 4 is okay, but let's see. That's 1 under. Not getting any flex on anything, I don't think. And then 3 above. So yeah, it's 4. It's probably okay right there. So anyway, got lucky on my shims. And of course it wasn't 9 thousandths, guys. And then I've got to take this apart again and then put an oil seal on here and lubricate the shims. And of course, when you lubricate the shims, the oil thickness between them is going to change it. So it's going to be pretty tight, but that's the way that's what they're designed for. That 4/1000 or 3 to 5/1000 is designed for the thickness of oil on each one of the shims. That's the way I understand it. So anyway, that should be okay. All right, guys, here we go. We got the heads back. So what I had them do is open them up for the 81s, and I think the tops of the 81s are a little bit different than the 80s, just so you know. So I had them take the cylinder down, measure, make sure that it, is below the surface and all that. Made sure that this is not going to conflict with the piston going all the way to the top. So we've got, what we did is we did a 40 thousandths. So we opened up for 81. We did a 40 thousandths deck. We decked these down 40 thousandths. And then what we did is a 40 thousandths step. So if you can see here, this is 40 thousandths deeper than normal. And this step is another 40 thousandths. So we've gone, this edge right here is 80 thousandths below where it normally is. Okay, that's, so it made the cylinder, we were trying to make a little bit more combustion, a little smaller combustion chamber, because these were 50 cc, and based on the information that I put in the computer, it came out to like 7.1 to 1 at 80 cc, at 50 cc. I forget what it was, something like that. It was just too low. I wanted a little more compression than that. So, and plus the other thing I was trying to do is make the engine more narrow, okay? A little more narrow, so it'd be easier to get in the car. 80 thousandths more narrow is basically, because it's 40 thousandths each side of the engine. So that's what we ended up with. Now I checked the CC on these, and they are 45 cc, which is a little bit smaller than I was hoping. So 45 cc is what I ended up with. And the spark plug does not conflict. The top of the spark plug, that's another thing I've checked here. Drop a straight edge in there, make sure she's not going to hit or be below your deck height. Because what we're doing is we're going to run like a 10 thousandths deck height on the piston to the cylinder, and then we're running the rest of our deck height right here, this step, okay? So we have a total of, between this surface right here, see the step right there, between this surface right here and the piston, we have 50 thousandths, which is fine. They said even 40 on an engine this small is probably okay. Because it's such a small engine, and we're not going to be running a lot of RPMs, we're talking about, you can run a little tighter deck height. It's just up to you. You decide what you want to do. This is how we're doing this one. So we got a 40 thousandths step, 40 thousandths deck. We decked it 40 thousandths. So we got a combustion chamber, and I'm going to end up with, currently, I believe right around 8.5 to 1, which is, again, a little bit higher compression. I wanted an 8 1/4. We ended up with 8.5. 8.5 will work fine with the heads, with the bigger valves. Remember, we have bigger valves in stock. They're not big valves, but they're bigger valves in stock. And we have dual carbs, so we have more air and fuel. So you're always thinking about how much air and fuel you're getting into that combustion chamber, and then the compression it needs to squeeze that. And are you going to have too little combustible fuel, air fuel mixture in there, and that is going to make it run like it's running lean. It's called air fuel volume. So you have air fuel mixture, and you also have air fuel volume. Sometimes what I'll do is, if I go a little bit too much compression, then I can increase my air fuel mixture a little bit to kind of make it a little bit more rich. Okay, and sometimes that helps on the other end if you go a little too far. but it just depends. It's better to do it for the right volume that goes in for the compression that you have. And you calculate that based on, it's a little bit of backyard ingenuity. There's probably some sort of algorithmic thing to do it with, but based on the size of the valve being bigger and the cam being bigger than stock and running a dual carb setup, we're going to have enough air and fuel volume in here to make the 8.5 compression fire nicely. I mean, 8.25 would have been perfect, but we went to 8.5. So if I was doing this again, I would say go 30 thousandths on the deck at 30 thousandths and do a 40 thousandth step. So we're going to figure out now is we're just going to put the head on here with no pistons in there, and then we're going to check our push rods and see kind of where they end up. So I can figure out how to shim them. There's instructions on how to lengthen the stock push rods, and I guess what you do, well, if we have to do it, we'll show you a little bit later. You put this in a vise, okay? Use a rag or whatever. Put it in the vise carefully. Squeeze this down real tight, and then use either a pry bar. I think a wrench would be easier. Take a open end wrench and put it on the end of here, and pry the ends off. And then when you take this end off, okay. Somebody was saying to take this end off, but I don't think you do that end. It's showing this end in the instructions. And then they give you these shims here. So there's that option. Or you can spend a little more money and you can buy the lifters that take a cut-to-fit push rod. So they make a lifter, AA makes a lifter like this, just a lifter by itself. See, normally the 36 horse came, let's look at one out of the package. Here's one of the original ones. Came with a lifter like this that's all one piece with the push rod. So, and AA makes one that the end of it, it looks like the end right like this, but it has a regular push rod end in it, and it's not one piece, it's a two-piece push rod. And then what you use is you buy the cut-to-fit set and put the cut-to-fit push rods in. Now, I will tell you, those are very pricey. They're about double the price of putting the shims in these, more than double the price. So that's why we're going to try and do this with the way that Wellsburg West sells it, and just put the shims in. So I measured these shims. I think they were 105 thousandths. So let's kind of go over the calculations of what we would have normally done with this. So if I went to a regular 60 deck, okay, if I went to a regular pit, my deck was at 60 thousandths, okay, and then I put these on here, we would have I'd have to add 50 thousandths in shims. So that would be, this is an 80, so 80 plus 50. So 80 plus 50 is that 140 thousandths? 140 thousandths worth of shims in there, which would widen this engine quite a bit. All right, because that would be, okay, 125 thousandths, 0.125, is an eighth of an inch, right? So it would be wider than a quarter of an inch wide on the engine. So this is why I'm trying to narrow it up a little bit. I guess it would fit in there that way because that's the way this kit was made. But the thing that I believe in is trying to get as much fire in the head as possible and get less in the barrel. This is what a lot of us do. And the way I do that is try and go a shorter deck height and then step cut. So you can either do step cut or you can do, a lot of guys will do the copper head gaskets. Well, we don't have the option of doing the copper head gaskets. They don't make them for these. You'd have to have them custom made. So step cutting is, to me, the best way for this engine. In fact, I think it's better. They're good and bad about the copper. The copper has a softer landing for the head, between the head and the cylinder. But the issue is, like, you know, with the VW, you're not able to get them as tight. You know, you're only going on this one because it's 10 millimeter studs. we can go to what, 24 foot-pounds. Some guys go 25. I don't know. So I'll say 24 foot-pounds though. Versus if you want 8mm studs, then you can only go to 18. Okay, and 18 with the copper, sometimes, you know, it can, you know, the copper has a little bit of crush rate, and literally, when you start them up with copper, you run it for just like a little bit, and run it through the break-in, and then readjust the, you know, tighten the heads again, because they're going to be loose. They will be loose after the first time you run it. So because I guess whatever it is, the compaction rate of the copper. So that you do that a couple times, and then your head ends up coming a little bit closer and closer, so you don't want to go too tight on your deck with the copper head gaskets. Little tricks there. It's just something, his learning curve is there, you know. So anyway, the copper works great. You guys, I'm at, okay, we took 40 thousandths off the head, so the head is 40 thousandths down, and we put 80,000 shims down here. So our total change over stock is 40 thousandths. All right, so we've widened the engine 40 thousandths because of the way I did it, right? Because I took 40 thousandths off the head, added 40,000, added 80,000 shims. I was trying to go and take another bit off the tops of the pistons, but so you know, the piston is 170 thousandths to the center. I took them to Brothers, we looked at them, and we didn't feel like that was enough piston. If we took, there's no way we could do 80, or I was thinking, I think was thinking 60 thousandths off the top of the piston. No possible way to do that. So even the most maybe you could take off these maybe is 20, and even that, they're kind of thin at the top, right here, right in the center. All right, so halfway through the valve cycle, well, you guys can see, I had to do this one. I would like to do the end one, but this is the one I ended up with. I had a little trouble trying to get the lifter to go in. I'm going to fight with that a little bit. But, I mean, it's so close that I think it's going to be perfect with the lifter adjusted with the stock push rod length. It's like right in the middle. I mean, and it's straight up and down, pretty much straight up and down. So you can run it all the way through, see where it is before, and when it goes all the way down, it's a little funky because the rods can get, that's like all the way down right there, I think, and then halfway up. I have looked at the dial indicator to really get it in the right place, but where it's halfway up, it's like pretty much perfectly straight up and down. I mean, I don't think I can get it any better with without shimming it. You know, it's so close, it's not even worth it, really. So anyway, that's great. So that eliminates decking the heads and then step cutting it and bringing the, you know, getting that piston to fire in the cylinder with the 80,000 shims on here on mine. I mean, it's going to be different on every block because you deck your block a little bit, right, when you opened it up. So, man, you know, that's like right on the money. And look where when it's adjusted, look where the adjuster is. That kind of gives you an idea. If the adjuster's way at the end, then you know you're going to have some sort of an issue. But it's like right in the middle of the adjustment. It's got a couple threads showing. So, yeah, I'm going to say that is fine without the shims. Awesome. So I reached my goal, even though I didn't quite get what I wanted. That extra 40 thousandths didn't really make enough difference on the width with the cam. When you add the higher lift cam and then you add the 40 thousandths, it comes out just right on the money without having to lengthen the push rods. Sweet. All right, so these rings only can go on a certain way. The oil rings are pretty much self-explanatory. They're like any other oil ring, but if you look here, it says on here top. That goes on top, and that's the middle ring. The top ring is a different width than the middle ring. So I just get them on like that. Drop them in. And then the top one, look for the thing that says top. Put it on the same way. Do all 4 pistons the same. All right, I wanted to show you guys this too. If you can see here, this is softened edge. I'm gonna go ahead and sand that a little bit with some finer paper, but you can see how that is. See how that is really sharp. So when the piston goes up, if it helps it kind of flow to the combustion chamber, to the spark, to the exhaust, or the intake, that's going to help it burn a little cleaner. So I'm going to clean this up real quick with a little bit of sandpaper on a disc, and do the other head the same way, and then I'll put them on real quick. All right, let me show you. So that's what we ended up with there after the final sanding. I don't know if I showed you that. But just cleaned it up a little bit, got it smoother. And another thing I found, I've had the head off of this thing, I don't know, half a dozen times now. I had to open these up quite a bit. They were way too small for any socket to fit on there. So yeah, that was, so I got it opened up for a real thin socket that I have. It just barely fits in there, so had to do that. A lot of work there. All right, so CC these up after making these little bit of changes here, and I added 2 more CC, so it gets to 47, and that makes it like 8.4, which is closer to where we want to be. There's my ring compressor. I tried to film a few times and software updates, all kinds of stuff. So anyway, I went ahead and used a pinch welder and I cleaned the terminals on it, and boy, it starts to work good again. So I got that working good. Got those all on there really good. And I put little patches on here. I want it to look like if I wanted to ever take these off, I could just peel these off of here. Okay, and put heat risers on it. And I'm not sure if what exhaust I'm going to put on here. I may have to put something on there. I don't know. So I'm going to go ahead and paint this stuff. The device I was using filming this, I broke it. It fell off the good old stand. Didn't have a good enough magnetic setup on it. So anyway, hopefully I can get the footage off of it for, I don't know. You'll find out if the video has footage from the build, then we're good, right? So got it all put together. Put the generator on. Put this on. I don't want to drop this in until I know where my distributor is. I suppose I could if I put the fuel pump on this one. You can't. This has a different fuel pump on it. So I don't know if I can put. So normally your fuel pump will drop down here, right? And hold that thing in, hold it down on the gear. Because you don't want it to, you don't ever want to put one of these together and not put a distributor right in it after you put the drive in. Because if you don't, when you go to turn this around, that drive can jump up a little bit and tear up the brass gear in there. So we don't want to do that. So anyway, I've got to find my distributor. I've been looking for it. I haven't found it yet. I may just put something else in here temporarily, or 009 or something. Whatever I've got laying around, but it needs to work with 6 volts. So it's going to have points in it, which that's scary. But anyway, we're going to get these cylinders tins painted and then put them on. And then I'm not going to paint the shroud yet because I don't know. I think the coil has to get relocated. So I may use this shroud that's kind of roached and then re-weld it and fix it, because if I'm going to re-weld and fix one to work with the thing in a different position, then rather than use one that's junk, because this one here is not too bad. It would be good for a stock engine. So I may just use the other one, and I think that one's earlier too because it doesn't have the holes for the wiring things on it. So that'd be more appropriate for this car. So anyway, we'll do that. But again, I'm not going to paint it until I mock it up, because I got to put the cylinder, you put those on there, put the carbs on, put the linkage on, figure out where they need to be mounted to the shroud. And then, because I don't know how that goes, we'll find out. I don't know. So I got to find out where that's going to get mounted, or if it screws to it, bolts to it, if I use nut certs or weld it, I don't know. So we'll get to that a little bit later. And then once I get the cylinders stuff painted, that's why I got to get that stuff painted now. This is a great DTM sealer. I just shot everything with that real quick. Alright, so check this out. They got a pattern in here. Same thing as the head. So this one here is good, has a good hole here and here for the cable. So now I just got to cut this out like magic and then tape it in place like we did the other one. Got this bracket in the way though, but make sure that hole lines up. Those two holes line up. You can see it should line up like that, and then I got to get it straight, and then I'll scribe that. I just lined this part up because it's got that bracket right there, but just lined it up good. And then this hole and this hole were lined up. That's the most important thing, I think. And I'll just go ahead and scribe it like so. And I'll just grind a little bit right here, a little right here. Spot weld it in. All right, so I got the bracket on here. I almost wish I would have moved it over just a little bit, because the eyelet for this is off center. I don't like stuff like that. I like it to be right on, because I didn't know where this was going to set. So these are little things you guys can learn from me. Where it shows on the pattern, it's exactly on the pattern that way, but I would try and move it over about 1/4 of an inch. Yeah, about 1/4 of an inch. So I may end up cutting it off and moving it over, and then you can move this rod, which it's not threaded opposite on one end than the other, which is kind of a pain. So you have to pull this thing out, which is not hard, and then just loosen this up and lengthen the rod and shorten the rod and get it so that it works right. So those are the issues I've gone to so far. And there's another one. So another thing is on this fan shroud, I don't know if it pulls forward more or not. I'm pretty sure that's going to be a conflict right there. So this, let's see if we can get you guys nice and close so you can see. This thing hits, so when the linkage pulls, I'm already got the throttle open, so it pulls, and then I was wondering what it was hitting, and it's hitting right there. So I'll probably have to grind that out. There's little fitting issue, you know, little fitting things you got to do. It's not just like a total bolt-on kit, but you know, I can move that thing over. Look, kind of sloppy in there. Maybe if I do that, does it? Oh, it still hits. If I do a little more, there, now it goes to full throttle. Yay, that's what I was looking for. And where's full throttle at? That's why I was looking. Full throttle. Okay, well, I'll just grind that out first. I may end up leaving this where it is. Because it's off center here, and then when it goes to full throttle, it goes to center. So I got to decide whether I like that or not. Those are all things that, you know, like when it's all the way out here at idle, I guess it's centered, isn't it? And then you pull on the throttle, and it goes off to the side, and the nut falls off, and it goes off and it stops there, but as it goes to full throttle, it goes back to the center again. So maybe that is okay. I guess it is. I don't think there's anything else I could do to make it better. We'll play around with that, because I don't like my cable rubbing on the side. That gets me a little, makes them wear out. So maybe I'll put a buggy throttle cable in this one to make sure it doesn't wear out on me on a long trip. All right, those are the issues. All right, so now you guys know why I didn't paint the fan shroud, right? Okay, so all the way out, we're lined up. I mean, it's hair off center, and all the way full throttle. It's centered in there. So that's probably the best thing when you're putting it, you're putting your foot in it, right? Yeah, and it's, let's see. Yeah, it's in the right position. It's at the right height is what I'm looking at here with this thing. Looking through the hole, it's a straight shot. So at idle, it's lined up very straight, full throttle. So I'm going to say that was the right place to put it. So if you look here where mine is, See how close it is. See if I can get you guys in the right position where you can see. If you see how close it is here, make sure that that distance between that hole and the edge of this thing is the same as the pattern. Then it looks like that would line up right. And so when it's full throttle, it's pulling the hardest, right? And that's when you definitely want it to be lined up. If it's off center, you know, I mean, you could say, well, when you're driving around town or whatever, and you're on it, you know, that's when you're going to be using it the most, right? It's going to be kind of a little off center, because there's no way with this linkage, it doesn't, that's why I like the ones, the hex linkage, because it goes exactly the same throw as the angle of this does. So they don't jack up throttle cables as much. But this is cool. I mean, this is original. This is a reproduction of the original throttle linkage from Okrasa. Now the other question is the location of the coil. Because obviously you can't put the coil right here. Where it normally went, right, is up here. That's the other thing. Remember, that's why I used this shroud. I didn't want to butcher up a shroud that that I couldn't, you know, that was stock. So this one here is really great for cutting up. It's nice and straight. It's a really straight, nice looking shroud. It'll paint up real nice. I'll fill up these holes. They had a bolt, a carriage bolt all the way through. Because, you know, you can't get a weld nut up in there very easily. So, you know, that's what I would usually use. I don't like those nut certs, but I have those. So I could put the coil, or I'm seeing other guys that put them. They put them right like this, I think. Let me see. Yeah, that's not going to hit ever. Let's see. It goes all the way full throttle. Yeah, there's no way. Just think about it. I try and, whenever I do stuff like this, you guys, I sit there and I think about, okay, what are all the possibilities of things that can happen? Now, number one, I definitely have to have 2 bolts on this thing. So I'd have to put another one down here, because let's say if I only put one and this came loose and it twisted up like this, and it got my throttle stuck when I'm like that. Okay, those are things that I look at. I call it idiot proof. No matter what the idiot is that's driving it, what is it, all the possibilities of things that can happen. And then I have to figure out the spring thing. I don't even know what this is and how it works. So I got this to do. So it's a lot of figuring. I mean, I look at it all and then I look at the book or whatever, but I don't know. I don't see a diagram for this. So I'm seeing that this thing should go on here, right? The end of that goes on there. And then it needs something fixed. Okay, is this, if it pulls that way, is that idle? Yeah, that's idle. Full throttle here, idle. So if the spring is, oh, I see. So it's the spring and it has a little bracket on there. Oh, maybe the little bracket goes on the alternator. So this is idle. So the spring needs to be pulling this direction. That's full throttle, that's idle. So it has to pull this thing like that. So somewhere it attaches over here, and then it attaches with that little thing there, I think. I'll figure that out. I mean, it's just all in the book, I guess, but I'll look at that and, you know, interpret it. And then I can get this thing painted, and I gotta mark this with a paint marker real quick. Let's try a grease pencil, see if it works. Kind of. My paint marker's out and about somewhere. That should work. Yeah, I can see that, can't you? Alright, so I got those holes welded up. I got a T-nut welded in right here. You know what that is? It's a little weld nut thing. I call them T-nuts. I don't know why, but it's got 2 spots you can weld it in. So that'll be there forever. Whole coil's not going to fall off, not going to break off or anything like that. You can get the throttle. Burp. I wish it wasn't so stiff though. I don't know. Maybe it's just the carburetors inside or a little. You know, that's what the guys are saying, that you need to have these things. Probably I can just see these things aren't going to last, the throttle shafts or whatever. But yeah, that could be. I could rebush them. I could do that. I could take it out, but you got to drill a nice straight hole through there. If it's a little bit wonky, it'll bind up, and that's no good. So yeah, that would make it probably work a little bit easier. But yeah, that's what worries me right now, is like if I have to pull on this throttle hard like that, and it's a little hard. I'll see if I can get that less binding, but yeah, that's because I put a spring on there, spring tension on it to hold it back. You know, it's going to break the throttle cable pretty easily. So usually what I do in this circumstance is I'll get a buggy throttle cable, and I'll run the buggy throttle cable through here, and then I'll cut it, you know, whatever length, and then I'll tighten up the ends of it and braze it. You need a torch. You can't do that with anything else. Well, I guess you can do the TIG welder, but I'll braze the end of it, and that brass on there will keep the thing from unwinding. That'll last forever. That's a throttle cable. The throttle cable is the size of a clutch cable. The buggy throttle cables are, so, and they're not cheap, but they work. And then it won't, if it's binding up a little bit like that, or it's kind of hard, you have to have a lot of spring tension. And like I said, I want to try and eliminate that, but still haven't figured that out yet. I mean, I'll play with this thing for a while. But that's it, guys. I think what we need now is we need the exhaust. I don't have one yet. Stainless steel. I got some of that, but I don't know what I'm going to put in it yet. We were talking about just bending one out of steel. One of the issues is stainless is, when you bend it, apparently it likes to wrinkle one side of it when you use mandrel bender. So, but then trying to find 4-inch big tubing, it's kind of hard. It seems like it'd be easy to find, but you can find stainless pretty easily, but the other stuff is not like everywhere. So find this 4-inch tubing if I want to make a stock exhaust. But I could make one out of stainless. I think I can do it. I mean, I don't know. We'll see. I'll see later. That's what we don't know right now. So we'll just kind of play it with ear on that. Then I've got to sandblast and paint this. Sandblast and paint my generator, my generator stuff. I got a 1600 fan. I think a 1600 fan will fit, but I don't know for sure. So you can always comment that below if you know. I'll look and see if I've got one. It's either 1600 or 40 horse. I don't know if the 40 horse is more narrow than the 1600, but something with the same width as this one. I think the 40 horse or the 1600 one of them will fit in here. So I'll put that in here, then I'll get more air. And then I got this on. The notch was off. I checked it. TDC on that pulley when I had it apart. Again, I've remocked it twice to make sure the deck height. Total now with it torqued, I checked it torqued and everything else, we're looking at 8.6 with the clearance stuff I did. So it's like I said, it's a little more than I want, but I think this thing's gonna like it. I think it's gonna help the gas mileage, because I'll get a really clean burn. And if I have to, it's got the main jets that are in here are 125s. I don't know if that's going to work or not. I may have to richen it up and then see if it runs like crap. And then if it runs like crap when it's rich, then when I put bigger jets in it, that'll tell me that I need to go with the 125s. I just want to know. I don't want to guess. If it's, if I over richen it, that's cool. I'd rather have it be rich, too rich, or just right than be too lean. So anyway, we'll try it and we'll see. It's gonna be a little bit of wait before we get to a will it run. Maybe we'll just do the rest of the stuff in the next video and do a will it run on this, and hopefully, you know, it all depends on the exhaust. I'm still waiting on stuff, so we'll see on that, and then I'll finish putting together, make it run. I don't know if I'm going to do it in the car. I might just do that. And I got to get a distributor. I'm working on that right now. Laszlo might have one for me, and when I told him, I said, yeah, just, you know, we'll do a trade, and then I'll probably give him my other one when I find it, because I think I've got one. I know I do. I've seen one, but I have like 30-40 buckets of parts that I need to go through up in the attic. That whole attic is full of parts. Tons of stuff in there. So once I get in there, then I'll know what to do with the distributor. And that's why I can't drop the drive. So I'm kind of stuck on that. I'm just going to sandblast and paint this. And I'll bring you guys back in. I'll just do that off camera. And I'll take the thing off here, and I'll find a fan if I can. Then I'll put these clamps on. I don't want to do that till after I got everything, so I know it's where everything's going to be. Then I'll put these clamps on. Some cool clamps they give you in the kit too. They're like ancient looking, really cool. Like, I don't know, they have a cotter pin in them and roll them up type of thing. Kind of weird, like something they would have put on this originally. So that's going to go on here. So I went with this on the rear tin because it looks like something originally they would have done. So I did that with a patch on there. Hopefully you can see it. Like, it looks kind of glary in the video, but I can't tell. And thank Josh. I don't know. He has the notchback. It's a really early red notchback original car. He found this for me. Thanks, Josh. Appreciate it. I was looking for this thing for a while, and I kept on getting skunked. That shows he saw two of them, and he needed one, and he thought about me and got it for me. So now I don't have to worry about that. I know this is probably not the right year one, but it goes underneath the fuel pump. You can't see it, so I don't care. The right one might have had no little groove in it. I don't care. I'll get that thing put on. I don't know, I have that little Z thing, I think, that goes in here. I thought Tony gave me one to put in there. Hopefully he did, because it's supposed to have, one of the issues is now you're running more RPMs, and that little thing in there helps it from getting, I don't know, having blow-by issues or whatever, or what's it called, going down the breather tube, the oil, I don't know, crankcase pressure issues, because we got a kind of weighted crank and 69 stroke, and we're running more RPMs, so we need to be thinking about that as well. I don't think we're going to need to vent the valve covers or anything like that. I think just that little thing, Z thing that goes down there, will take care of that. It's supposed to be. So anyway, it's kind of fun to work on these. It's definitely different. You know, it's every little thing takes hours just to do one little thing. You know, like putting this linkage on. I did this I don't know how many times to try and figure it out. I just was like, how the heck? And I didn't really like the leverage of that, but that's just, I don't know. It seems to work, but I'm wondering why it's kind of hard to do. Maybe if I just lubricate the carbs, it'll work. I don't know. Just throw a little lube down in the things. We'll play with it. Well, I picked up this from the swap meet in that pile of stuff for $50. The engine case and all that stuff. And I was looking at it. It looks like it was rebuilt. So I cleaned the armature. Piece of sandpaper. You can see the brushes look new. And at first it didn't work because I didn't clean the armature. I cleaned the armature and I hooked up power to D+ over here. All right. And then I ground this side. And it just sparks. That's what you want. Okay. If you hook up D+ and you ground this and it starts spinning, then you might have a grounded out armature if this is disconnected. This is your field wire. So then what I do is, after that's connected, is I ground the field and it spins. So that tells you it starts to make an electric motor. So that tells me that this thing is good. Of course, I had to have the regulator disconnected, but look at that. This looks like brand new, like somebody replaced it at some point. So I know this isn't exactly the correct one, but that's fine as long as it works. That's what I'm hoping for. And the other thing that's cool is this coil bracket. Let's see if we can get in the light so you guys can see and get a close up. Same time. I don't know if you can see that, but there's a Bosch emblem in there. Pretty cool. So I'm going to paint this silver. I got some real automotive type silver paint. A single stage urethane satin. That's what everything is on this, is going satin. And this was originally black. So I've got the new stickers coming, the original stickers for it. So that would be black on this one. Like I painted them blue. That's cool. I'm not doing it. I just figured I'll go with the original. So here's this all painted. So I bent this thing kind of somewhat close to what they showed. And it drops in like that. So it'll just deflect some of the oil that wants to fling back up in there. And I painted these like a metallic finish that I had laying around. So I gotta glue this thing on. I think I'm just gonna glue it in place. That gasket. All right, so this is either a 1500 or 40 horse. I don't know which one, but it's the same size. I don't know. I think the 1500 and the 40 horse were the same, but I don't know. But it's the same width, so it's got more blades than this one. So it should create more air, is what I think that they did. That should be good. Warning, what you're about to see could be quite devastating. No, anyway, here's my TIG welding. I'm not the TIG welder, especially for stainless steel, but I'm getting it to stick. So I'm gonna make this exhaust. Again, guys, we're gonna make like a kind of like the original exhaust was. I bent these pieces and was learning how to TIG weld stainless steel. I've done it. I mean, we did the parts. I can just barely get it to stick. And, you know, of course, there's holes in that. And then I had to, these are little pits, okay? They're not holes. I've looked it all over with the light and everything, and it's fine. So, anyway, people are like, hey, just buy the one from whatever, Vintage Speed. You know, I don't have the money for that, guys. I don't have money for $800 exhaust system. I just don't. So I have other things I need to spend money on, and that's not one of them. So anyway, I'm making this thing go like this here, and I'm making these flanges, waiting for some stuff for that. So that's one of the reasons it's been a delay. Again, I'm learning how to TIG weld. I've never done much TIG welding before, and stainless steel is definitely even more difficult than regular steel. So I would prefer poking my eye out with a pencil than welding with a TIG welder. So I would rather not do it, but if it's necessary, I just have to do it. So I'm working my way through it. I bent these by cutting slits in here. I don't know if I showed that earlier in another video, but I built a bunch of slits in there, I bent it, and then welded up the slits. So anyway, that's how it looks. It is smooth inside pretty well. So the exhaust should flow through it okay. back down. It's a little lumpy, but it's fine. It's better than not having it. So anyway, but yeah, I can run in there with a, I'm probably going to go in there with a die grinder and kind of clean that up a little bit, and that's it. We're going to run with that. I've burned some holes, Arlen. Just what it is. Eventually I could always redo it, you know, the way I'm doing it now. I could always redo it. That's what you do with body work and everything, car stuff. You do it once, yeah, maybe I'll do it better next time, and I'll do it again. And that's what I'm doing. So anyway, got that going, and we'll see how it goes. I'll check in with you guys a little bit later. I'm not going to film me TIG welding. It's just too painful. I'll talk to you guys later. All right, so I'm getting ready to put this engine back in here, and you know, I've always looked at this and kind of been a little bit kind of ambivalent about whether I should have a firewall protector in here, you know, or the I don't know if this car ever had one, because look at these tabs, they don't look like they've ever been bent. That one doesn't, that one doesn't, that one doesn't, that one doesn't, that one, yeah, I don't think it has either, because it's bent like perfectly like this one is. It doesn't look like it's been bent out. That one looks like it was bent. That one doesn't look like it's ever been bent out, and that one doesn't up there. So if you look, this one does, these two don't, but this one does maybe. Okay, and that one, I don't know, maybe that was just from when I was restoring this back here. So why were those never bent? You know, why do they look like that? I don't know. Was it optional to have the firewall piece in here? I don't really know. So I don't know. I'm not sure if I'm going to put one on. So I guess I'm just going to put the engine in without it and then go from there. But it just freaks me out a little bit, because I thought they had them. I thought it was in the split windows that they didn't. But I don't really know. So anyway, if you guys know, then of course your comments would be definitely appreciated. And yeah, we'll do what we can. That's part of the headliner. And just go with that for now and clean this out, I guess. Once I get the engine in, I'm going to wash it all out later, and then we'll look at it then. But yeah, I don't know really what was there. It's just weird. So anyway, maybe they didn't have them, it was optional, I don't know. So I gotta put the throttle bearing in, get this engine ready to put in here. All right, so I'll tell you guys where I've got, how to get it to this position. Is I had this carburetor over there in that corner, that carburetor there off, and jacked it up. Of course, normally when you go up with a VW, you go up and you go outward this way. And then, so that's why there's always damage here. Every VW has some scratches or something there. Of course, we're going to touch that up, but I'm not worried about it. I didn't even put tape down there because I already know I'm going to touch it up, and it's just too much aggravation for me to try and do all that stuff. I don't get upset anymore. I just know it's going to happen. So let it happen, deal with it. Okay, so what I did is I get it up this way. Now, of course, then you take it back like this. You get the stud started, and then you bring it in like that. That's your typical way to put in the VW engine. And once you get it up high enough, the manifolds are clearing, so it should be fine. It should go in like a normal engine now. It is hopefully normal. Can vary quite a bit. Well, I hate to disappoint you guys, but it went right in. So yeah, I was shocked actually. So anyway, if you didn't see got some stickers there from Europe for the Bosch coil. I just got to put this thing together now, so I'm just gonna stick the carb back on. I loosened that one up. I didn't need to. I could have just, I was going to take that one off. I thought, well, why would I take that one off when that one has the linkage I can remove? So it's easier to take that off, and then I would just take off the linkage as well, or the fuel line. You could probably leave it on, but I don't know. Yeah, you probably could, but it's probably easier to put the engine bolts in with it out, because you got to reach your arm back there. So yeah, I think I'd rather have it out of there. So anyway, I took it off. It takes a couple minutes to put on. So anyway, let's get on with it. I'm going to go ahead and assemble some of this up off camera. It's kind of self-explanatory, right? And then I've got to fit my exhaust on. I got it all done, but when I was welding the inside pieces, of course, it warped a little. I don't know, I have trouble with stainless steel. It's guys say it's easy. I don't think so, but anyway, it's my opinion. I got the carbs back on there. I don't know about this. I'll just leave it that way for now. I think I'll end up putting a buggy throttle cable in here. I just know that that's going to break. So anyway, but the throttle linkage does work good now. It's not when I push on it, because it's not meant to be pushed on. But yeah, it does work very good. It returns real nice. I can tighten up the spring a little bit more. So that's working good, but we'll improve it as we go. Somebody mentioned that they like the one that goes down here better. Maybe it does work better, but sure to conflict with a lot of things if it's down on the case. Maybe it's up higher, but does it go all the way up to here in the same place but just mounts on the case? I don't know. Those are supposed to be better, I guess, but this is what we went with. This is original. That's what I kind of wanted, the original look. So anyway, so let's look out. We're looking right now. I haven't got the belt on. I don't have the spark plugs in it yet, but I did hook up the exhaust. Wow, it came out pretty straight. Holy crap, I thought it was going to be crooked. But, and it's like the perfect length too, isn't it? The other one was too long. Anyway, a lot of TIG welding off camera. Good. Let's see if we get oil pressure. And it's cranking over pretty well for a 6-volt. Oh, it's going faster. It's going faster. It must be getting some oil pressure. Maybe let's make sure it's not going on the ground. So I don't know if we're going to get the oil light. I see it flickering. I see it flickering. Look, it's like it's thinking about going out, but maybe 6 volts just doesn't crank it over fast enough. But that gained up oil pressure pretty quick, because we did full flow this, and we put a 26mm oil pump on there. We've got 1/2 inch line going up to the front. Most of the guys use 1/4 inch on the 36. I went with 1/2 inch up to the filter and back, because I don't want it to run dry for any amount of time. So I went with that. Yeah, it's not as pretty. Let's look underneath, I'll show you. So this is where I put it. The spin-on filter's up here in the front. And when I do a Beetle and I put oil cooler in it, put it right here. Gets lots of air, works really good. The filter can go right where that one is, and there's usually enough room right here. Now, the problem is these bulky heater boxes, I still got to put the covers on them. I don't know how that's going to go. And I've got the oil lines. I usually like to run my oil lines down like this, and on the later models, I'll use those bottom bolts there, and I'll put like a little U-bracket right here to hold them. Anywhere else, it seems to conflict with the exhaust. So if I run it straight out here, then it's, you know, it's kind of close to the exhaust. Some guys put them over here. I don't know. I like them going down underneath and going here with the AN fittings. And then what I'll do is I'll put, buy some plugs if you're going to use the AN style fittings. Buy some plugs so that when you take your engine out, you just take these off. Okay, and you put a plug in each end. You put a plug on this side and a plug on this side, and a plug here and a plug there, and then you don't have oil spilling all over the ground when you're taking your engine out. It's just not bad that way. All you got to do is put the oil pan underneath it, put your plugs in, clean it up a little bit, and then you don't have a bunch of mess while you're taking the engine out. And then these come, just roll them back, and then I just use baling wire here because I just untwist this. I don't use zip ties because zip ties come off or they'll break or whatever, and then your oil line's hanging down. So I'll use baling wire because it's pretty permanent, and I can undo this and then take this down if I want to and move the lines way up out of the way, whatever, while you're taking the engine out. So that's the way I like to do it on a Beetle. It's been a long time since I had a full flow in a Beetle. So anyway, that's how we do them. We used to do them this way, to the side of the transmission and over. So this all this. A couple of years back, I bought some of these. So I bought a bunch of them from House, Arizona before. I didn't even know they were going to stop making them. Just a little bit of starting fluid. This isn't the good stuff like the old days. So anyway, see if it starts. Fuel's puking. Fuel puking right out of here. Gotta fix that. You guys over here for a second. See if it's puking again. I don't know. I just saw it just squirting out of there. Oh, it doesn't seem like it is now. Probably going to need 12 volts to get this thing to start. Let's see. Has it got any fuel coming in yet? Have to tighten up the spring a little bit. Saw something falling down there. I don't know. I think there's fuel in there. I think this trigger's too short. Well, if I jump it with 12 volts, I'll kill my battery or my lights. See fuel coming out somewhere else. It's kind of wet. I get my glasses out, I can't see. Okay, so I don't think it's going to start unless I let it charge for a while. Maybe let this charge. Let's see. I'll show you how slow. It's just too slow. And it's I don't think it's getting enough spark when it's going that slow. So I need to spin it over faster. If I hook up a 12 volt one to the 6 volt, one of the jumper packs, they don't work real well on the lithium ones. Don't work really well on a 6 volt car. They start cutting off and stuff. So I got to charge this thing for a couple hours and just see if it comes back around. Then by then this sun will be over that tree and it's not so hot. All right, I put a little 12 volt on it for a while and then tried it, cranked it over. So let's try this thing with 6 volt again and see if it starts. I don't know. It seemed like it might. It's trying to. Plug's disconnected. Number 3 or number 4. Plug's disconnected. Let's try hooking it up. Can't run it very long. I don't have the fan belt. What I got's not the right one. I guess I just didn't plug it in. I didn't plug in 2. God, it runs pretty good on 2 cylinders. Holy crap. Jerking around with this thing for so long. Got to plug them in. Alright, let's try it now. Whoa, this thing sounded pretty good for 2 cylinders. Let's see. Looks like on all 4. That's an exhaust leak. I think that's all we're going to do there. It's getting hot. No fan. Well, at least it runs. It sounds pretty good. Can't believe I just forgot those stupid plug wires, putting the plugs in. Just didn't see them sitting there. I checked the spark and it didn't have very good spark. That was part of the issue. So I got the spark working. Cleaned the points, a little bit of film I guess maybe on them, and when it's 6 volt and it's going that slow. So anyway, I think I'll go down and get a fan belt for it. I don't know. I don't even know if they have the right size one anymore. They didn't have them for a while. See if I can get one and we'll run it for, gotta run it for the break-in. But yeah, and I got stuff falling off everywhere. So anyway, at least it fires. And maybe I'll, once it heats up a couple times, then I leave all the back tin off, because then I'll tighten up the exhaust bolts again, because they'll be leaking for a while. I hear some ticky-tickies, a lot of it. Alright, so let's bring you guys back in shortly. Alright, we got a belt on here. Gotta turn it on. Gotta set the timing too. Let's see. And start it up and idle it. we're good. I'm going to bring you back in. I got about 10 more minutes here. So, like after 20 minutes break in, let's see if I can set this up a little bit. I haven't synced the carbs yet, but not too far out. I'm gonna have to tighten up this spring quite a bit. This thing's mean, man. It doesn't sound like no 36 horse. A little sit back over there. Alright guys, this thing is cool. Definitely has some juice. It just barely touched the gas. It drives so nice.